Hi everyone, welcome to my channel School Coaching Point. Today we'll discuss one important topic, complex number from class 11. Download the PDF from the link given in the description box. Subscribe and press the bell icon for more videos. So let us recall our previous knowledge. Ax square plus bx plus c equals to 0. A, b, c are real numbers. A not equals to 0. So represent a quadratic equation. So b square minus 4ac equals to 0. It means equal roots b square minus 4ac greater than 0. Roots are real and distinct. So b square minus 4ac greater than 0, roots are real and distinct. B square minus 4ac less than 0, roots are not real. B square minus 4ac less than 0, then roots are not real. So roots are not real means the values of x or the solution of x should not belong to the set of real number. The solution of x should not belong to the set of real numbers. Set of real number means x should not be a real number. X should not be a real number. That is, x should not be a real number. So x should not be a real number. So b square minus 4 is a less than 0. So roots are not real. So we have already discussed that means the solution of x should not belong to the set of real numbers. That means how can you find the value of x? If x does not belongs to a real number, so we should use some concept for finding the values of x if x is not a real number. That time we should use the concept of complex number. So when x should not be a real number or b square minus 4 is less than 0, we should use the concept of complex number. So first of all, let us define a complex number. How can we define a complex number? So a plus ib is known as complex number. That means any number which can express in the form of a plus ib is known as complex number. So any number if you can write in the form of a plus ib is known as complex number, where a and b are real number. So a and b are real numbers and representation of a plus ib is a complex number where I equals to root over minus 1. So this is the point you should remember. The value of I should be a root over minus 1. So this representation is known as the complex number. A plus ib is a complex number. For example, 5 plus 2i is considered as a complex number. So let us discuss the part of a complex number. So let z equals to a plus ib is any complex number. Basically z is represent a set of complex number. So here a is known as the real part A is the real part and B is the imaginary part. B is what? Imaginary part. So a complex number has two parts. One is the real part, another one is the imaginary part. Why it is imaginary? Because it is associated with I. B is attached with I, that's why B is known as the imaginary part. So real part in short form we can write REZ is A, and imaginary part you can write in short form IM bracket Z equals to B. So let us take some example. 3 plus 2y. So in this case, suppose z equals to 3 plus 2y, real part r is z equals to 3 and imaginary part I am z equals to 2. So this is the way to describe a part of a complex number. Real part and the imaginary part. So let us discuss some properties. Let Z1 equals to A1 plus IB1, Z2 equals to A2 plus IB2. So these are any two complex number. If Z1 equals to Z2, if these two complex numbers are equal, then A1 equals to A2, B1 equals to B2. It means the real part of Z1 should be equals to real part of Z2, and imaginary part of Z1 should be equals to imaginary part of Z2. So let us discuss another question. If 4x plus I bracket 3x minus y equal to 3 plus I bracket minus 6, find x and y. So 4x plus I, 3x minus y consider as a Z1, and 3 plus I bracket 6 we consider as a Z2. So Z1 equals to 4x plus I bracket 3x minus y. So real part of Z1 is 4x, imaginary part of Z1 equals to 3x minus y. Z2 equals to 3 plus I bracket 6. So real part of Z1 equals to 3. Imaginary part of Z2 equals to minus 6. So Z1 4x plus I bracket 3x minus y. Since Z1 equals to Z2, it is given in the question. So therefore, real part of Z1 should be equals to real part of Z2. So this property we have already discussed. If two complex numbers are equal, then their real part should be equal, their imaginary part should be equal. So real part of Z1 4x, real part of Z2 3. So x equals to 3 by 4. Similarly, their imaginary part should be also equal. Imaginary part of Z1 equals to imaginary part of Z2. So imaginary part of Z1 3x minus y, imaginary part of Z2 minus 6. So you can put the values of x. 3 into 3 by 4 minus y equals to minus 6. 9 by 4 minus y equals to 6 minus 6. So by transposing y equals to 33 by 4. So 9 plus 4 into 6, 24. 9 plus 24 by 4, y equals to 33 by 4. So this is one of the important question. So in this case, z1 and z2 are equal. We need to find the value of x and y. So in z1, we consider as z1 as 4x plus I, 3x minus y. Real part is 4x, imaginary part is 3x minus y. z2, 3 plus I minus 6, real part 3, imaginary part minus 6. So since z1 equals to z2, their real part should be equal and their imaginary part should be also equal. So real parts equal means real part of z1 equals to real part of z2, so x equal to 3 by 4. Similarly, imaginary part of z1 equals to imaginary part of z2. So 3x minus y minus 6, putting the value of x. So after simplification, y equals to 33 by 4. So let us move to the new topic, conjugate. Conjugate of a complex number. So how can we define a conjugate of a complex number? Suppose z equals to a plus ib. Then conjugate of z is represented by z bar equals to a minus ib. That means when a complex number is a plus ib, its conjugate should be a minus ib. This plus sign should be replaced by minus sign. So let us discuss one question. Express in a plus ib form. So this is very important questions from the examination point of view. Express in a plus ib form. So 1 by 3 minus 2y. This is the question. So since 3 minus 2y is in the numerator part, so one thing we should remember, there should not be any imaginary part in the denominator. So we should convert the imaginary part into real part. So 3 minus 2y should be multiplying by its conjugate. 3 minus 2y multiplying by 3 plus 2y, because 3 plus 2y is the conjugate of 3 minus 2y. So when a imaginary number is in the denominator part, so we should multiplying by its conjugate. So if z equals to a minus ib, then conjugate should be a plus ib. Since 3 minus 2y is there, so 3 plus 2y is the conjugate of 3 minus 2y. So multiplying by its conjugate in the denominator as well as in the numerator. So 3 plus 2y, it is a square minus b square. Three plus 2y, 9 minus 2y whole square means 2 square into I square. 3 plus 2y, 9 minus 2 square means 4, I square means minus y, because we know that I equal to root over minus 1. So hence I square should be equals to minus 1. So 3 plus 2y, 9 plus 4. So 3 plus 2y divided by 9 plus 4 equals to 3 plus 2y by 13. Therefore, the required a plus ib form. So what should be the a plus ib form? 3 plus 2i by 13. So we can write 3 by 13 plus 2i by 13. So a equals to 3 by 13, b equals to 2 by 13. So express a plus ib form. So once again we'll discuss 3 minus 2i, which will be multiplying by its conjugate, because in the denominator part there should not be any imaginary part. So the denominator part should be multiplying by its conjugate. So root over minus 1 equals to I. So minus 1 should be equals to I square. So I square can be replaced by minus 1. So 3 plus 2i divided by 13. So a equal to 3 by 13, b equal to. So let us discuss one more question. Express in a plus ib form. Express in a plus ib form. So here is the question. 1 plus I whole square divided by 3 minus I. So 1 plus I whole square, a plus b whole square form. So a square plus twice ab plus b square divided by 3 minus I. So 1 square means 1, 2 into 1 into I means 2, twice I, plus I square means minus 1, 3 minus I. So 1 plus 2i minus 1. 1 and minus 1 we can cancel. So 2i by 3 minus I. So in this step we have seen that the denominator part is occupied by a complex number, and we have already discussed there should not be any imaginary part in the denominator. So multiplying by its conjugate. So multiplying by 3 plus I, because conjugate of 3 minus I is 3 plus I. So 3 minus I into 3 plus I, twice I into 3 plus I. So twice I into 3 plus I, it's a minus b, a plus b, a square minus b square. So 3 square means 9, and minus I square means minus bracket minus 1, because root over minus 1 equals to I. Hence I square should be minus 1. So twice I into 3 is 6i, twice I into I, twice I square. So 9 minus minus plus 9 plus 1, 10, 6i plus 2 into minus 1. So minus 2 plus I6 divided by 10. And don't confuse with 6i and I6, both are same. 6i and I6 both are same. So 2 by 10 minus 2 by 10 plus I 6 by 10. So 2 by 10 means minus 1 by 5 plus I 3 by 5. So A means minus 1 by 5 and B means 3 by 5.